Okay, you still there?
Yep.
All right, let's get started here. So we're pretty close to done this kind of unit. In fact, we're almost done everything that I'm going to bother teaching you for this course. I have like 2 lessons left, but
Okay.
all right. So we're just kind of, there isn't too much more to learn. It's going to be more just doing these last 2 lessons and then just practicing stuff. And then we'll just have a couple of different assignments to finish up the course. And then you're good to go, and you can go outside and melt away underneath the hot, hot sun.
Okay.
All right, so this is kind of a catch-up, or this is kind of a throwback to something we've done before. So we're looking for a point of intersection. So we have 2 lines here, and I want you to look at the hint here. So we have hint, you'll need to rearrange the second line for y before you can solve the system. All right, so here's equation number 1, and this is equation number 2. All right, so we need to rearrange equation number 2 in a y equals kind of formula. So
Okay.
I'm going to put y equals, for equation number 1, y equals negative 3x plus 2. Equation number 2 was negative 4x All right, so what we need to do is put this in a y equals scenario. So we need to get rid of everything else. We just need to get the y on one side. So what I want to do is I want it to end up being 2y equals something. So to get 2y by itself, what do I have to do to the other things that are sitting beside it?
You still need them to the other side.
Yep, you can bring it to the other side, exactly. So if I bring negative 4x to the other side, what does it become?
Positive 4.
Good, so I got 4x there. And if I bring plus 16 over, what does it become?
Negative 16.
Awesome. So now I have 2y equals 4x minus 16. Now what do I need to do to get it so it's just, I want it to make it so it's just y equals something. What do I need to do to get it just so it's y?
Only have to divide it.
Divide, yeah, exactly. I'm going to divide this, and I'm going to divide everything. And what am I going to divide by?
2.
Very good. See, you're a rock star. This is wicked. So I'm going to divide by 2, and this will cancel out. So do you know what the last line is going to be then? What's 4 divided by 2?
2.
Yep, so we got 2x, and then negative 16 divided by 2?
Negative 8.
Very good. So there's our second equation. All right, so that's one equation, and we have our other, the first one. Let's go back to the first one here. Y equals negative 3x plus 2. All right, so to solve for points of intersection, or solving we call the system, that means we need to let the 2 equations be equal to each other. So we're going to let equation 1 equal equation 2, meaning like the y values are equal. So I'm only going to take the back half. So equation 1 was negative 3x plus 2 is equal to, and then we already figured out equation 2, we had 2x minus 8. All right, so I want to get all the x's to one side and all the numbers to the other side. How are we going to do that? What do you think?
We can move the positive 2 to the... Wait, no, never mind.
Yep.
We can do negative 3x
Okay.
and move it to the other side.
All right, let's do that. So if that goes to this side, it becomes what?
Positive 3.
Okay, good. So we end up with 2x plus 3x.
And then the negative 8 becomes positive.
Yes, very good. So that's going to go to this side. So we end up with 8 plus 2. All right, so now we can simplify this, and it becomes 2 is equal to 5x. Now we just need to solve for x. And how do we do that again?
And we have to divide it.
Okay, and what are we dividing by?
5.
Yep, awesome. So what's our answer?
2x.
Yeah, so x equals 2, like this. Or you could have written it like this, x equals 2. It doesn't make a difference. It's the same thing. All right, so when we have an x value, basically what we're doing is we're solving for the point of intersection, so we're getting coordinates. So if we know the x value, we need to solve for the y value now. So to solve for y, we take either equation, like we can take equation 1 or equation 2. Let's take equation 1. And we had y equals negative 3x plus 2. And to solve for y, we just have to substitute in the value that we had for x. So negative 3 times 2 is negative 6 plus 2. So y equals negative 4. So therefore, the point of intersection is 2, which is our x-coordinate, and negative 4. So we know that those two lines meet at that exact coordinate. All right, so that was a long time throwback. I'm not sure if you remember that one completely, but maybe that one will help refresh your memory a little bit. Yeah. Okay, next we're going back to the parabola. So that's kind of our goal today, is looking at the parabola, and we're going to do something called vertex form. That's kind of the whole point of what we're doing today, vertex form. All right, so if you remember the basic parabola that's shown below, so this follows this equation, y equals x squared. And if we made a table of values, basically, so if we had an x and a y, we said when x is 0, y is 0. When x is 1 or negative 1, y has the same value, which is just 1. And we could do 2, negative 2, and it was 4, 3, negative 3, 9, so on and so forth, right? Okay. Like these points right here. Okay, so we can find the vertex and the step pattern. So the vertex, if we recall that, do you remember what the vertex was? What the vertex is? What?
Kind of.
All right, guess. Guesses are good. What does this word vertex mean?
I have no idea. I forget.
That's okay. It's been a while. We haven't looked at parabolas for a little while. So vertex is kind of like the maximum or minimum point.
Okay.
So it's basically as low or high as that parabola can possibly go. So the vertex in this case here is this thing right there. That's the vertex. All right, and so in this case here, the vertex is at 0, 0. Does that make sense?
Yeah.
Okay, so that's the coordinates of the vertex. So the other thing we learned before, and like I'm not sure if you were here for it because we learned this kind of early on in the course. I know you kind of transferred in a little bit later, but yeah. So we did something called step pattern. That's this thing right here. So step pattern means it's how far up or down. Here, I'll write it a little more legibly. It's kind of messy. Okay, so it's how far up or down the parabola goes when you move sideways, when it goes sideways one, and I'll show you an example. Okay. So if we look at our parabola here, and we start from the vertex, and we go over 1. And how far up or down does it go? It goes up plus 1. And so if we went over 1 again, we're going up plus 3. And we could look again. We could go over 1 spot again, and we go up plus 5. And if we went to the other side, we would find the exact same thing. We could go over 1 here, and it goes up 1. And then, so because it's symmetrical, so it doesn't really matter which side we go to, the step pattern will always be the same here. So I'm going to highlight those values. So we had plus 5, plus 3, plus 1. So in this case here, our step pattern, and this is the step pattern for our standard parabola of y equals x squared, is 1, 3, 5, and it goes on and on. Numbers that you can hopefully figure out. All right, so if that's the standard step parabola, let's again look at, we're going to look at another parabola, and we're going to enter in the values here. So I'm going to fill in this table, and we're going to explain why it's called vertex form and why it helps us. All right, so this thing here, vertex form, is an equation of a parabola. It's an equation of a parabola in a certain order. All right, so let's fill this in for a second here. So when x is negative 4, there's going to be some tiny writing on my part. So if I substitute in negative 4, I get so I have to do in my brackets first because of BEDMAS. So I end up with negative 3 squared minus 4. And I'm going to continue over here. So 2 times negative 3 squared. So negative 3 squared is 9 minus 4. So I get 18 minus 4 equals 14. And I could do the same thing with the negative 3. So negative 3 plus 1 is negative 2 squared minus 4. And now I'm going to do the exponent. Negative 2 squared is just 4. So I get 8 minus 4 equals 4. And I'll try this one. Negative 2 plus 1 is negative 1. It's going to be squared. Negative 1 squared is just 1. All right, we're almost there. Just going to keep filling this in a bit more. Negative 1 plus 1 is 0. 0 squared is just 0, so 2 times 0, which is just going to be 0. Almost done it, and we should start seeing a pattern here at this point. And it's going to become more obvious right here when I fill in this one. So again, a parabola is symmetrical, so it has to have a bottommost point. And we've already found it. So the bottommost point is going to be the -4. And you're going to see here that when I do this last one, or second last one, I'll do them all, I guess. That a pattern will become apparent. All right, last one. It should be also obvious or more apparent that my hand is getting tired, so my handwriting gets crappier as I go on. All right. I'm going to highlight these last two ones here. Okay, so if we look at our values, what do we notice? We got equals 14, equals 4, equals 2, equals -4, equals -2, equals 4, equals 14. So, and we're going to add that all onto the graph. Oh, as much as it actually fits on there. Let's start off with the -1, -4. And the reason why is because that's the lowest the y gets. -1, -4 is right there. And 0 is at -2. And 1 is at 4. And 2 is at 14, so that goes off the charts. Whoops. 1 is at 4. And the thing is, it's symmetrical. And we can see that in our points, so that when x is -3, the value is 4. So our coordinates here, again, so we have like -3 and 4, -2, so these are giving us x and y coordinates. And if we were to draw this parabola, it's my best attempt to do it freehand. It looks something like that. So basically, let's rewrite that equation that we're given at the very top here. If we rewrite this equation, which is this one right here. Y equals 2x plus 1 squared minus 4. All right, so let's look at the equation for a second. And this is in vertex form. And so what actual vertex form is this equation right here I'm about to write out. And this is going to be with placeholders. All right, so each one of these letters represents something different. So if we look at this equation, y equals 2x plus 1 squared minus 4, and we look at the thing that we've drawn on there. If you look at our graph, we'll notice that we have a step pattern of 2. this plus 2, it corresponds to this plus 2 right there. That 2 is our step pattern. So the very first thing that's in the equation, where the place where that letter A is, that is the step pattern. That's the value of the step pattern. So whatever the number is, that's how we know what the step pattern would be. So if we're drawing that parabola, the first step would be over 1 and up or down depending on whatever that value is. So the other thing I want you to notice is that, let's look at our vertex here. We have a vertex of -1, -4. All right? So that's our X and Y coordinates. Now, do the numbers -1 and -4 pop up in our equation? They do. This number here is +1, which is not -1, but I'll explain to you why it's actually indicating the -1 for us. And what they both do is they tell us the X and Y coordinates of the vertex. So what's happening here is the +1 and the -4, in our example, we could say, based on that, the vertex is -1 - 4. And what's happening is the +1, the value is always the opposite. So I'm going to write that in small letters. So if it says +1, the X coordinate is going to be the opposite, which is, so it'll be -1. If it was -1 there, it would be +1 for the vertex. So it's whatever it is, it's the opposite is kind of the key thing. So that's what's going on in our standard equation, is that we're given any numbers in those two spots represent the coordinates of the vertex. All right, and the key thing then is just remembering that this is the opposite. Opposite sign. All right. So, if we did an example, let's do another example here. Okay, so let's look at our standard thing here. Again, the letter A represents step pattern, and H and K represent the vertex. We just have to remember the opposite sign. Now let's look at some equations just below this. All right, if we have a parabola with a vertex of 3 and -5 and a step pattern of 2. So put that on there and write the equation. So let's put on, we already know how to put it on. Let's put it on right quickly. So the vertex is at 3, -5, and a step pattern 2. So let's do that first. So 3, -5 is right there. And a step pattern to 2 means we go over 1, up 2. Over 1, up 2. Now, it only works for the first step, that over 1, up 2, because the step pattern changes, so the second step wouldn't be the same. So if you look at the standard step pattern, we had 1, 3, 5, and we have to, our A value is 2. We multiply that 2 by each one of the standard steps. And we end up with 2, 6, 10. So our next step would actually be over 1 and up 6. 1, 2, 3, 4, 5, 6. And that's on both sides. So if we were drawing this parabola on there to complete it, it would look like this. Okay, now for the tricky part, using what we just learned. So we have to put it in we want the equation. Let's write the equation here. So remember, we have y equals a x plus h squared minus k. I think that's what we have, or plus k. It doesn't really matter. The h and k are just placeholders. All right. So our step pattern is 2. That's the easiest place to start. So the letter A becomes 2. All right, so the letter A is 2. And then we look at the vertex. So based on the information we have from the vertex, what goes in this spot in here? So if we look at our coordinates, whatever the x coordinate is here, we have to do the opposite. So if we're getting plus 3, our vertex is at negative 3. And then y never lies. Y always stays the same. So whatever the y coordinate is, we just write it in, whatever it is. It just stays. So negative 5 stays negative 5. So this becomes negative 3 and negative 5. Let's try the second one here. Let's just go straight to the equation. So a parabola with vertex of negative 3 and 4 with a step pattern of 1, or negative 1. So the key thing there, let's start off with that step pattern. So y equals, where that A spot is negative 1. We're going to put the negative 1 right out front. And then we just have to use the vertex, this coordinate here. So y never lies, so the y value is 4, plus 4 stays on the end. And then we have the other value, negative 3 is for x, so we're going to do the opposite. So it becomes plus 3. And let's look at the last one here. So we have a step pattern. It's a little bit different this time because it's a decimal, but that doesn't change anything really. So we're going to go y equals 0.5. And then x, and it's the opposite of this, right? Opposite, so it's plus 4 squared, and y never lies. So if that's plus 5, it stays plus 5 like that. So that's our equation. All right, so you can graph those yourselves as practice. And on here, there is a few more parabolas that I want you to try. Yeah, and we'll leave it there for now. The rest of this year is for practice on your own. All right, any questions?
No.
Okay, I know that might be kind of confusing, but if you give it a try, and if you have problems, let me know. And I got a lot of extra homework for that one, so give it a try. There'll be a quiz on it. later on this week, and I'll try and make it pretty simple. And yeah, any questions, hit me up, and make sure you try and get anything done that is left on our assignments. And again, if you want to try again, just let me know and I will repost it.